Hey there, 8th grade learners, and welcome to this explainer. I am absolutely thrilled to have you here today. We're going to master a really essential, incredibly powerful math toolkit together. You know, we're stepping totally out of the theoretical textbook today and looking at how math actually shapes the physical world around us. By the end of our time together, you won't just be memorizing numbers, you're going to be armed with the exact same mathematical framework that engineers, designers, and creators use every single day.
Okay, let's just dive right into it with a question you've probably never stopped to think about at a birthday party. How much space does a helium balloon actually take up? Think about it. If I handed you a standard round helium balloon right now, how would you measure the exact amount of gas inside of it? I mean, you can't exactly pop it and pour the gas into a measuring cup, right? Well, that is the core puzzle we are solving today.
Because here's the thing. Understanding volume isn't just some abstract math exercise, it's a critical real-world skill. Think about packing everyday products into massive shipping containers, or think about designing the fuel tanks for airplanes, or engineering safe, highly efficient machines and structures. Engineers and designers absolutely must know how to calculate volume accurately. If they just guess, well, a machine might not work, or a structure might not be safe. By connecting this math to real situations, you are literally learning how to make the decisions that build our world.
All right, moving into section 1, the spherical volume formula. To make all those crucial engineering decisions, we need a specific tool. And here is your master key. Volume, represented by V, equals 4/3 multiplied by pi multiplied by the radius cubed. Let's break this down so it's crystal clear. The V is the total three-dimensional space inside the sphere. The 4/3 is our constant fraction. Pi, as we all know, is our mathematical constant, roughly 3.14. And then we have r cubed. This simply means taking the radius of the sphere and multiplying it by itself and then by itself again. So radius times radius times radius. This little formula right here is exactly what tells us how much space is inside that helium balloon we talked about a minute ago.
But before we start crunching the numbers, I've got to warn you about the ultimate math trap, knowing the difference between the radius and the diameter. So the absolutely crucial point here is that the radius is the distance from the dead center of the sphere straight to the outer edge. The diameter, on the other hand, is the distance all the way across the sphere passing right through that center. If a word problem gives you the diameter, you cannot, I repeat, cannot just plug it into the r in our formula. You have to cut that diameter in half to find the radius first. Always, always double check which measurement you're being given.
Which brings us to section 2, real-world math in action.
Let's put this into practice and apply our new formula to some actual scenarios. Back to our birthday party. Example 1. A helium tank fills 3 spherical balloons, and we're told each one has a radius of 3 inches. Step 1. We identify our radius. It's 3. Great, no diameter trap here. Step 2. We run the formula. First, we cube the radius. 3 times 3 times 3 is 27. So our formula becomes volume equals 4/3 times pi times 27. When we calculate that out, the volume of one single balloon is approximately 113.04 cubic inches. But wait, we aren't done yet. Step 3. The problem asks for the total volume of all 3 balloons, so we multiply that 113.04 by 3, and our grand total is approximately 339.12 cubic inches of helium needed. Okay, let's ramp up the difficulty just a tiny bit. Example 2. Imagine a massive spherical fish tank. The problem says it has a diameter of 20 inches. Step 1, boom, spot the trap. They gave us the diameter. So step 2 is our vital conversion step. We just divide that 20 in half. Our radius is actually 10 inches. Now for step 3, we plug it into the formula. 10 cubed, so 10 times 10 times 10 is 1,000. So we calculate 4/3 times pi times 1,000. And when you run that math, wow, you get 4,188.79 cubic inches. And this brilliantly illustrates how much water that really is. I mean, just by roughly tripling our radius compared to that small balloon, the volume absolutely explodes into the thousands. This right here is exactly why engineers have to be so incredibly precise. Visual estimates of a sphere's size are wildly deceiving compared to the actual volume inside.
All right, let's do one last example, and it's a delicious one. A chocolate company makes sphere-shaped truffles. They tell us the radius is 2 centimeters. Step 1, the radius is clearly 2. Step 2, cube it. 2 times 2 times 2 gives us an r cubed of 8. Step 3, solve it. Volume equals 4/3 times pi times 8. The volume of a single truffle is approximately 33.51 cubic centimeters. If you work in that factory and need to know exactly how much chocolate to order for 10,000 truffles, this is the exact math you'd rely on.
Time for Section 3, Test Your New Skills. So, you've got the formula, you know how to spot the traps. Now it is time to test your skills. Here's a quick preview of your homework challenges. For question 1, you're calculating the space of a balloon with a 7-centimeter radius. Nice and straightforward, but look closely at question 2, a decorative glass ball with a diameter of 12 centimeters. Remember what we talked about, don't fall for the trap. Question 3 requires some real critical thinking. A water container holds 2,680.8 cubic centimeters. You actually have the volume here, and you need to reverse engineer the formula to find the radius. Question 4 asks for the total volume of 5 identical balls. And question 5 asks how much water is formed when a snowball with a 3-centimeter radius melts. Approach each of these methodically, write out your steps, and trust the formula. You are completely ready for this.
Finally, Section 4, True Education and Morality. As we wrap up the math portion today, the source material from the heroesmartacademy Godly Learner series shifts focus to a pretty fascinating foundational philosophy. The curriculum emphasizes a, quote, education without morality will hurt. It basically intertwines biblical morality with education to ask a really critical question. What is the point of being incredibly smart, of knowing how to engineer massive structures or run complex companies, if you just continue to make bad choices that cause hurt to yourself and to others? The idea here is that a brilliant mind without a moral compass is kind of like a powerful engine without a steering wheel. It can cause a whole lot of damage.
To address this, the curriculum points to Romans 8:6-7, which outlines a promise of peace of mind to everyone who keeps their mind spiritual. According to the Academy's framework, when students align their education with this spiritual grounding, they don't just gain knowledge, they actually gain the wisdom to use that knowledge to build up rather than tear down. So as we conclude today's explainer, the source material leaves us with a final, really provocative thought. You have the formula to measure the volume of the physical world, but how will you measure the impact of your life? Will you use your education to build a brilliant mind and your morality to build a peaceful, spiritually grounded life? Take that question with you, right along with your math homework, and I will see you next time.